Welcome to the Electron Security Workshop organized by Doyensec. My name is Luca Caretoni, and in those 2 days I will be teaching you how to build a secure desktop application using Electron.js. Alright, let's start looking at the agenda for the class. We'll start introducing Electron, its internals and ecosystem, so basically how Electron works. We'll then jump straight into the security model and what are the risks associated with using the framework. We'll then divide the discussion in two main topics: subverting the framework, so breaking Electron itself, and subverting custom code, so breaking the application that you are building. Finally, we'll discuss RDNA mitigation to then jump straight into conclusions. So when an Electron application starts, the framework will look for a package JSON, which is basically a manifest describing the application itself. One of the main components would be the main process, and the main process is what the framework executes as the first piece of code of your application. From there, you will normally spawn and create new renderers, whether you use browser window, a browser view, or a web view tag. So now that we know how protocol handlers works in Electron, let's look at one of the vulnerabilities discovered in the window protocol handler. And this was probably the most severe bug in Electron up to date. So let's have a look at some example of insecure preload, and let's start with a case study of Discord. Discord is a very popular gaming app, and it's made by a single browser window with Node.js primitives by basically disabling node integration. Despite enforcing isolation, the application uses a preload, and you can see an extract of the preload. In particular, you can see that is exporting something called native modules. Let's take a look at how a full chain exploit for a typical Electron-based application works. Exploits are generally made by three components. The first one is responsible for taking control of the DOM. So the attacker needs somehow to be able to execute arbitrary JavaScript. And this is done through, for example, a traditional cross-scripting vulnerability or more specific type of attacks like middle click or drag and drop. So let's review what will change in Electron v5. Electron v5 is going to be the security game changer. A lot of these settings will be secure by default. So for example, node integration will be off, while context isolation, which as you know prevents prototype pollution attacks, will be on. And with this, we jump into the conclusion for this workshop. We hope that this class will really help you to build secure desktop application. We have seen how Electron works and how to mitigate common vulnerabilities. We've seen some of the effects and some of the departure from best practice and departure from browser behaviors. And so it's really important that when you design and build your application, you keep in mind a few points.